Hello. Today we're going to continue on with indeterminate forms, the last three types, indeterminate powers. And before we actually do an example, I need to explain the algebra. Remember, L'Hopital's rule does not apply to these as they're written. L'Hopital's rule only applies to the 0 over 0 or infinity over infinity forms. And so we're going to have to convert these algebraically. So let me explain the algebra first. Let's suppose I have a to the b. Now I can rewrite this. This is the same as e to the natural log of a to the b, because e to the natural log of x is x. It's true for any real number x. Or then using the rules of algebra, rules of logarithms, this is e to the b times the natural log of a. So therefore, if I start off with the limit, whatever it might be as we're approaching, of the form a to the b, then using the algebra that I outlined, this is the same as the limit of e to the b times the natural log of a. Now, based on what we had the beginning of the semester with limit laws, since the exponential function is continuous, this limit can actually be moved inside that composition, and this is e to the limit of b times the natural log of a. Okay, you might be saying, that's nice. How does that help us? Let's see. Suppose in the 0 over 0 form, a is approaching 0 and b is approaching 0. So my original limit, which gives me the 0 to the 0 form, is the same algebraically as e to the limit of b times the natural log of a, based on the algebra I did. Well, notice here, if a is approaching 0, the natural log of a is approaching negative infinity. B is approaching 0, and so this is now a infinity times 0 form, or 0 times infinity form. Doesn't matter. And we dealt with that. Remember, based on what I just talked about last video, this would be natural log of a over 1 over b, and now this is approaching an infinity over infinity form, hence we can use L'Hopital's. Similarly, if I have a is approaching infinity, b is approaching 0, when I convert it, I get e to the limit b times the natural log of a. A approaches infinity, natural log of a is still approaching infinity, b is approaching 0, and so this is a 0 times infinity form. And when a is approaching 1, b is approaching infinity. When I convert it, a approaching 1 means natural log of a is approaching 0, b approaching infinity, and so this is an infinity times 0. So in all cases, we get a 0 times infinity, or 0, infinity times 0 form. And so therefore, we can use what we did previously. Let's look at a specific example of how this works. Suppose I have the limit. X approaches 1 from the right of 4 over pi arctan of x, I don't need that, quantity to the 1 over tangent pi x. Now, as x goes to 1, arctan approaches pi over 4. which means that this base is approaching 1. Tangent, on the inside we're approaching pi, tangent of pi is 0. And so this is denominator is approaching 0, which means the exponent is approaching infinity. And so we get a 1 to the infinity form. So I can do the algebra that I just talked about, and I'll actually go through the steps. This is the limit as x approaches 1 from the right of e to the natural log of this entire mess, 4 over pi arctan of x to the 1 over tangent pi x, or bringing this out front, I get the limit as x approaches 1 from the right of e to the natural log of 4 over pi arctan of x divided by tangent of pi x. Since that's in the denominator, I'm just going to go ahead and write it as a fraction. And I will now move this limit on the inside. And so we get then e to the limit of. And I'm going to use rules of logarithms here, make life a little simpler. It's the natural log of 4 over pi plus the natural log of arctan of x divided by tangent pi x. Okay? Now, this then, I can use my, this is the natural log of 4 over pi. This would be pi over 4. Actually, let me leave this alone. You probably would leave it. And then notice here that this becomes a 0 over 0 form. I'll just do it that way, it's easier. So then, I can use L'Hopital's, take the derivative. I get e, limit x approaches 1 from the right. This becomes 1 over 4 over pi arctan of x times the derivative of the inside, which is 4 over pi times 1 over 1 plus x squared. That's the derivative of arctan. All divided by the derivative of tangent secant squared of pi x times the derivative of the inside, which is pi. Notice these 4 over pi's reduce. That's what have happened before. And if I take the limit as x goes to 1 from the right, the arctan of 1 is pi over 4. This becomes 1/2, all divided by the secant of pi, 1 over the cosine of pi. The cosine of pi is -1. Secant of pi is -1, but when we square it, we get 1. So this just becomes pi. And so then I get, doing a little bit of algebra simplification, this becomes 4 over pi times 1/2 divided by pi, which is 2 over pi squared. That is my final result.